Good morning, students. Today we are going to start our third chapter, that is periodic table and periodicity of properties. In this chapter, we are going to discuss about the formation of periodic table and repetition of the properties according to this periodic table. As we know, in a modern periodic table, there are 118 elements, and out of these 118 elements, only 92 elements are naturally occurring. Other are formed by the disintegration of these elements. In the early centuries, scientists were very devoted to arrange elements in a systematic manner, and that devotion give us periodic law, and that periodic law is very helpful to arrange the elements in the form of table, and that table is now called as periodic table. Periodic mean the something that having a repetition. As we know, Sunday comes after 6 days. There is a repetition for Sunday. After every 6 days, we got Sunday. So I'm going to discuss with you or describe you various attempts which were made to classify the elements into a tabular form. Tabular form means in the form of table. And table is something that having groups, that having periods, that is arranged as a grid. So I'm going to start with the work of Dobereiner. Dobereiner was a German chemist, and he was the first scientist who tried to arrange elements in the form of groups. He arranged elements in the group of 3 elements. That's why Dobereiner's periodic table is called as triad, because he took 3 elements and made their group. According to Dobereiner's law of triad, arithmetic mean of atomic mass of first and third element of the triad is approximately equal to the atomic mass of the middle one, which means if you want to know about the atomic mass of the middle or the central atom, you have to take average of first and the third element of that group. You can see here, this is the Dobereiner's triad. At that time, only 30 elements were discovered, and he felt no difficulty to arrange these 30 elements. He took 3 elements and arranged them in a group of 3. If you are going to take the average of the first element, that is lithium, plus average of the third element, that is potassium, you will get the atomic mass of the middle one, that is 23. So by taking average of the first and the last one, you will get the atomic mass of the middle one. In this way, he arranged calcium, strontium, and barium. If you are going to take the average of the calcium and barium, you will get the atomic mass of the strontium. If you are going to take average of the chlorine and iodine, you will get the atomic mass of the middle one. So by Dobereiner's law of triad, you are able to know about the properties of 3 elements. Those were arranged in a same group. In modern periodic table, these 3 elements are present in group 1. So Dobereiner has tried something that is very useful in modern periodic table also, and calcium, strontium, and barium are arranged in group 2 of modern periodic table. Chlorine, bromine, and iodine, these 3 are halogens in a group 7 of modern periodic table. So Dobereiner's grouping are somehow correct, but when new elements were discovered, then Dobereiner's law of triad is not followed. So this classification of Dobereiner didn't get wide acceptance. Then Another scientist whose name is Newland, who tried to arrange the elements in a form of table or in systematic manner. According to Newland, there was a repetition in chemical properties of every eighth element if they were arranged according to their increasing atomic masses. So, by this statement, you can understand that the property of the first element and the property of every eighth element from that first element having a repetition of chemical properties. That's why Newland's arrangement of elements is called as law of octave. Octave mean 8 because there is a repetition of a property, chemical properties basically, after every eighth element. You can better understand this by this table of Newland here. Here you can see hydrogen, that is first element, and fluorine, that is eighth element from hydrogen, and chlorine, that is eighth element from fluorine, having same properties. In the same way, lithium, the first element, and sodium will be the eighth element from lithium, and potassium will be the eighth element from sodium, having same chemical properties. So according to Newland's law of octave, first element and the eighth element having same chemical properties, he arranged these elements according to their atomic masses. Hydrogen having atomic mass 1, as we know that, lithium having atomic mass 7, beryllium having atomic mass 9, boron having atomic mass 10, carbon having atomic mass 12, nitrogen having atomic mass 14, oxygen having atomic mass 16, and so on. So there is a increase of the atomic masses. So he arranged elements according to their increasing atomic masses. And after every eighth element, there is a repetition of properties. But at that time, only 56 elements were discovered. So when new elements were discovered, then there were difficulty to arrange those new elements because no spaces were left for undiscovered elements, and noble gases that were also not discovered at that time, having no space to be arranged in this table. So that's why Newland's law of octave was also rejected. After that, another scientist tried to arrange elements whose name is Mendeleev. Dmitry Mendeleev was a Russian chemist who arranged elements in the form of periods and groups. According to Mendeleev's periodic table, properties of elements are the periodic function of their atomic masses. He also arranged elements on the basis of their atomic masses because at that time atomic numbers were not discovered. So periodic mean repetition. So properties of elements are the periodic function of their atomic mass. There is a repetition of a properties in elements according to their atomic masses. At that time, 63 elements were discovered. Here you can see the arrangement of Mendeleev's periodic table, that how he arranged the elements. He arranged elements in the form of groups and periods. Here you can see 8 period of Mendeleev's periodic table and 8 groups of Mendeleev periodic table and 6 periods of Mendeleev periodic table. Vertical columns are called group and horizontal rows are called periods. So Mendeleev arranged elements in the form of groups and periods. And he stated that the properties of elements are the periodic function of their atomic masses. So here you can see elements are arranged on the basis of increasing atomic masses. There were many mistakes in Mendeleev's periodic table. He was failed to explain the position of isotopes. He arranged cobalt and nickel without following his own statement that properties of elements are periodic function of their atomic masses. Here you can see cobalt having atomic mass 58.93 and nickel having atomic mass 58.71. So cobalt having more atomic mass than nickel. But he arranged cobalt before nickel because nickel having the similar properties as palladium. So them he arranged nickel in this way. But this is a mistake because he said properties of the elements are the periodic function of their atomic masses. Another mistake of Mendeleev's periodic table is that he left the spaces for undiscovered elements. Those elements were not discovered at that time. So he left the spaces. So due to these mistakes, his periodic table were also rejected. So today we have discussed about the three early tries or three early attempts of the modern periodic table. First one is Dobereiner's triad, second one is Newland's octave, and the third one is Mendeleev's periodic table. These three tries or attempts of the modern periodic table are on the basis of the atomic masses. In our next lecture, we are going to discuss about the modern periodic table or the long form of periodic table that is based on the atomic numbers, because at that time atomic numbers were discovered by Moseley.